In this video, we'll do some more proofs with subspaces. So, like in the last video, we're going to let h and k be subspaces of some vector space V. And we're going to define h plus k to be the set of vectors W such that W is composed of one vector from h and one vector from V. So W is equal to u plus V, where u is in h and V is in k. So we want to show that h plus k is also a subspace of V. So again, there's three conditions we have to show. One, we have to show that 0 is going to be in h plus k. The second one, we have to prove that if we have, say, some vector w1 and w2 in h plus k, then we're going to get w1 plus w2 in h plus k. And finally, for the third bit, we have to show that if we have c, or if we have w1 in h plus k, then we're going to get c times w1 in h plus k for any scalar c. Okay, so for the first part, well, h and k are subspaces, so 0 is going to be in h, and 0 is going to be in k. Therefore, we can pick w equal to 0 plus 0, which is equal to 0, so that's going to be in h plus k. Okay, so that's the first part. The second part, we're going to have to define our w's. So how is a w written? Well, a w, a vector w, is written as a vector from u plus a vector from v. So w1 will be equal to u1 plus v1, and w2 will be equal to u2 plus v2. So we're going to assume w1 and w2 are in h plus k. Now we're going to add these together. So w1 plus w2 is going to equal u1 plus v1 plus u2 plus v2. That does not look like a u. Switch that. Okay, we're going to put all the u's on one side, all the v's on the other. So now we're going to get u1 plus u2 plus v1 plus v2. And what we see here is we see u1 plus u2. Well, this is going to be in h because h is a subspace. So if we have u1 and u2 in h, then u1 plus u2 will be in h. And v1 plus v2 is going to be in k for the same reasons. Therefore, w1 plus w2 is of the form of a vector from h plus a vector from k. Therefore, w1 plus w2 is going to be in h plus k. Okay, so now we need to show that it's closed under multiplication. So we're going to take c times our vector w1. This is the same thing as c times the vector u1 plus the vector v1. So when we multiply this out, this is c times u1 plus c times v1. So once again, this cu1 is going to be in the vector space h, or the subspace h, and cv2 is going to be in the subspace k. Therefore, our cw is of the form of vector from h plus a vector from k. Therefore, this is also going to be in the subspace h plus k. So the three conditions hold. Therefore, h plus k is a subspace of V. If you have any other questions, please leave them in the comments below, and I'll do my best to answer them.